everyone. Hey, quick shout out to Dylan. Thanks for running HalfStack. I absolutely love this series of conferences. Well, who am I? I am Luis Montes. I am Montes Lou on Twitter and GitHub and Gmail in most places. I do software consulting out of Phoenix. Hit me up. All right, so I am talking about creative coding. And what is creative coding? Well, it's a pretty loaded term, right? If you are coding, chances are pretty good you're having to be creative to solve anything. But this term is usually associated with writing something that's not necessarily functional, doesn't really serve a purpose. You're just kind of having fun and being expressive. Lots of times there's a visual component to this. So it's a type of coding I really enjoy doing. In fact, when I got my first computer, when I was a kid, I was doing GW Basic. So that was a form of Basic that allowed me to do some graphical things. I was able to change pixels, colors, and do some animations and write for loops and things like that. And I had a really good time with that. And then later on in college, I got into Visual Basic, which was more doing forms and buttons and fields and maybe putting things in a database. Still a lot of fun, a little different type of coding. Did C++, which, was kind of more of a tool to learn object-oriented programming. It worked pretty well for that. And I was doing mostly command line things. But it wasn't until I got, into Java that I was able to, have like a window that I can, arbitrarily set colors to and pixels and move things around and animate things. And what was really neat is I was able to take it from there and package it up into an applet and put it on the internet because, at the time, browsers knew what applets were. And pretty neat to be able to share something that you're working on. Some creative coding type thing that, you wanted to get out there. That was a lot of fun. One thing though is when you're doing this sort of thing, some of the setup, just getting started could be a lot. So there's kind of with some types of coding, there's a high barrier to entry to get started. What I really like about this application called processing, which started in 2001, was something you'd install. It's a Java application. And you just jump right in. You start giving it graphics commands and really simple things. Draw this, draw that, and do a loop and make some animation happen. Processing is really, really great for that. But if we fast forward into 13 or 14 years, Lauren McCarthy started this project, P5JS, which is great. That same concept of just sort of jumping in and coding and doing things visually is very much there with this. Also, a really inclusive, helpful, friendly community, and really, really easy to get started. And there's all kinds, you get all the things that a browser has, and this has, all kinds of plugins, machine learning, WebGL, all kinds of cool stuff. So this isn't specifically a P5 talk, but I do want to, real quickly show you, how you can get started with it. There is a P5JS editor. This thing is really cool. Similar to CodePen, but sort of focused around P5. But let's just jump in. Let's get started. So, really, really simple. We just have a setup and a draw loop. So setup runs once, draw runs, a bunch of times, like on a request animation frame. It's just something that's running really quickly. So in this case, the setup by default here, we're creating a canvas, and background says, paint the background. This could be RGB values. If it's just 220, it's going to be like a type of gray. But let's add just a little more to that. Let's actually draw something. So rect is a rectangle. Let's go, how about a 10 by 10? 10x in a 10y position, and then maybe 100 by 100 for width and height. And then all we got to do is hit the run button, and boom, we're there. We are coding. Now we can track the mouse location. We can add in a bunch of plugins, but that's all it takes, right? We basically just have a setup and a draw loop, and then we just start having fun and writing algorithms to do goofy things, to do animations, all of that. Really, really easy to get started with. So I really dig this this editor and P5 in general. But I also another type of creative coding I do is really around robotics. And when I saw this question pop up on Twitter, I'm like, oh, me, I know the answer to this one. Yay, I can answer a question. And the question is, how what's the easiest way to get started making things move around in the physical world here? And I'm sure a lot of people that are watching this, they already know the answer to this as well. It's use a microcontroller, Arduino. It's open platform, really easy to get started with as well. And you typically will have one of these things. You might have picked one up at a conference before somewhere, or you bought one and it's collecting dust or something. But this right here is actually a knockoff, pretty inexpensive board. But there's if you haven't done this before, real simple. These are called GPIOs. These pins. Now. They're general purpose inputs and outputs. So these ones over here in the corner, there might be for getting some type of sensor data. These, other ones might be for listening to a button press, or maybe, turning something on, or turning a motor or something like that. So you can do anything with these pins. And so how do you actually go from here to actually making something happen? Building a robot. Well, you typically what you do is you use the Arduino IDE. So this should look very familiar because it's actually based on that processing application. And just like processing in P5.js, we have a setup and we have a loop. Now, this setup here in this case is just telling one of these pins here, one of these GPIOs, to be in a certain mode output. And the loop here is saying, okay, turn a pin high, which means like turn a pin on. Wait half a second, turn it off, wait half a second, and just keep doing that. So that's effectively, you plug in a cable, you hit play, it compiles this sketch into some firmware, puts it onto this microcontroller, and you're up and running. In that case, we made an LED blink. And for some people, that might be where it ends, right? Okay, awesome, made an LED blink. It's kind of the hello world of electronics, is making an LED blink. And I personally, I went a lot further than just making the LED blink in my learning of Arduino, but I can totally understand that type of coding isn't for everybody. Also, it's that example there is this in this Arduino language is C, C++, and that's not for everybody as well. I actually much rather write in JavaScript. I like JavaScript. I enjoy it. I've been doing mostly Node and web developing for a long time, and that's where I want to be at. So can we do these types of things with JavaScript? And of course we can. This is a solved problem. This actually started a decade ago. Chris Williams made the first commit to the Node serial port repository in 2010, I think. And that allowed us to go from Node.js, which was new at the time, to send signals, into this, USB port here, and get signals back out, which is the ability to communicate with hardware. So we bridged, our JavaScript code to hardware. And that's great. That's an awesome first step. Now, that blink sketch that I showed a little bit ago, that's super useful for learning, but not super useful for interacting with JavaScript. That blink sketch is just something that's going to be running on this thing continuously when it powers up. But there's much more complex sketches that you can get just as examples built into the Arduino IDE. A really important one is called Fermata. Now, Fermata is a type of is a firmware that a sketch that we put on here. But what Fermata does is allow us to send signals to remote control things, right? So Fermata knows, hey, if I get this series of bytes come in, turn on this thing, or if I get this other series of bytes come in, start reporting our sensor data back out. So Fermata is sort of like a little server running on this thing here that we're talking to over a serial cable. And after Node serial port was ready, Fermata.js was another library that was built to sort of abstract sending those bytes over Node serial port to one of these guys. Now, that is also like, if that's all we had, then awesome, we could do all kinds of robotics things, but it's still kind of low level. A better abstraction on top of that was written by Rick Waldron and a bunch of other contributors. And what this does is this gives us, like sort of higher level objects like a servo and, actually a whole ton of things. And also similar to P5.js, a very inclusive community, really friendly people. And a lot of events around this thing. Every summer there's International NodeBots Day. We usually use Johnny 5, build robots, make them smash into each other, and just have a good time. But Johnny 5, has grown so much more than just that initial concept of talking to an Arduino Uno. But also having abstraction for other boards for, like Raspberry Pis and things like that, where they have more processing power to maybe run the JavaScript directly on here, so we're not remote controlling it over a wire. And there's also been a bunch of other libraries like helpers on top of Johnny 5. There's Node LED, which is to talk to like those 14 or 7 segment display like digital readouts. There's OLED.js to talk to little OLED screens. Node Pixel is a really nice one that lets us address those or talk to those RGB strips, of individual addressable pixels and grids to do all kinds of lighting animations and things. So really cool community around all of this. Now, what if we wanted to do the things that we do in browser with the things that we do with like Johnny 5 and Node serial port and all that? Can we bridge those things together? And from the outset, we really could. As long as we had Node, we could potentially set up like a Node server with maybe socket IO, and then have the web browser send commands to that to talk to the hardware. And that's a really cool thing to do. If you haven't done that before, I totally recommend it. But what if we want to do everything in the web browser and actually not even install Node, not install serial port, not even install Arduino, just take one of these out of the box and use the browser to start doing hardware stuff? It's actually possible. So there is a way to bridge this here. There's a couple of newer APIs that are in Chromium, and they're open source, open spec. But this might be a little bit confusing here. Why is there USB and serial? Because most of us might think that the serial, like this old school port that's here that might be on an old computer, this 9-pin port here, is what we might think of as serial. And it is. Those were serial ports. You plug in something, and on Windows it might say COM1, COM2, or on Linux or Mac it might be dev, TTY, whatever. And those are serial devices. But USB, generically speaking, USB Universal Serial Bus is these things that we plug into our computers, and the operating system might say, hey, I know that the ID on that device, I know what it does. So it's a mouse, it's a keyboard, it's a thumb drive. I've got a driver already, as part of the operating system, or maybe somebody installed a driver so it knows how to deal with that device and how allows you to use it. If you plug something in and the operating system doesn't know how to use it, you could potentially use WebUSB, because there's no driver already, nothing claimed that device. WebUSB lets you talk to that device. Well, and that's great. There's all kinds of stuff we can do with that. And WebUSB is a lot of fun just on its own. But when we plug in one of these, it's very likely that our operating system, we're plugging with USB, but what happens is the operating system says, oh, hey, that's a serial device. Even, it's a USB cable. It's not this old school port, but still the operating system says that's a serial device. And that's great because we have WebSerial and we can talk to those things. It doesn't matter if the operating system claimed it. It's giving us a COM port or whatever to talk to this thing. So sorry, long-winded. WebSerial, WebUSB, the distinction is USB is talking directly to the port when there's no driver installed. But if there is a serial driver installed, which there probably is when you plug in one of these, you can talk to it that way. Okay, so great. But we would still need to install Arduino to get that firmware onto this thing here, or we used to, until Suze started Suze Hinton started this AVR Girl Arduino project, which is a really cool project. Initially, took Node.js and Node serial port. You take a precompiled firmware, and you can use this to talk to a whole bunch of different microcontrollers and basically send that firmware over to them. And that's great because that means if you have Node installed already, you can just immediately start sending firmware to prep these devices so that you can now do Johnny 5 Node bots with that, and you don't even have to install the Arduino IDE. But it's all JavaScript, right? AVR Girl Arduino is a JavaScript code base. And we don't have to use Node serial port. We can use WebSerial. And we can put a shim around WebSerial to make it act as though it's Node serial port. and then sort of plug all these pieces together. And that's exactly where we're at right now. So there is some examples in the AVR Girl Arduino repository for doing some web applications based on WebSerial. So we could just plug in an Arduino Uno or a Mega, more board support. We have some issues open where we can support more boards besides those two. Anyways, we'll send firmware over. So we can prep these boards with that Firmata service on here, that firmware, just from a web browser because of WebSerial. Okay, great. So we have a board ready to go that's got firmware Firmata on it. What's the next step? Well, the next step is let's smash all these things together. Let's take processing. Let's take Johnny 5. And so I've wrote a plugin. I've written a plugin to do just that, to P5 and Johnny 5, match them all up so we can just put a couple of script includes in a page or use the P5 editor and an Arduino that already has this firmware on it and jump right in and start going. So let's do that. But right before we do that, if you haven't done much with Arduino yet or microcontrollers in general, these are really helpful. Breadboards. And if you haven't used one of these before, they usually have like some sticker or something on the back of them, and then you use jumper wires and you just plug them in. So you don't have to solder or tape things together, the wires together. You just use this as a prototyping board. And if we were to peel this plastic off on the back, you can see sort of how they're connected, so you'll know what you're plugging in together. Okay. So I want to real quick get into sensors, right? That picture on the screen is a potentiometer. It's one of these guys. It's got 3 little pins on it, a power, a ground, and a data pin. And we're going to hook that up to our breadboard and to our Arduino and see, can we get some data? So can we get some data into our browser from this potentiometer? And we totally can. So let's activate this camera. Okay, cool. All right, so I have this potentiometer on a breadboard. I've got a example in the P5 editor, and what I'm going to do is plug our data pin here into our analog 0. It's marked on the board what that is. Plug in a ground, plug in our 5 volts of power here. And in our sketch, or our P5 sketch, there's one little extra step here. I got to do this load board thing. And the reason is that in order to talk to WebSerial, we have to actually click a button on the screen. So that way you don't just go to some random web page and it starts talking to your serial devices. Instead, we have to explicitly authorize one of these hardware devices. And that's what this load board thing is here. And I'm stashing a little variable here for the sensor value, creating a canvas. Now, the little Johnny 5 API stuff is to create a sensor object, and then we get some events anytime it changes. Now, typically for an Arduino Uno, our sensor values are 0 to 1023, but we can scale that for the purposes of doing something visually. It doesn't have to be 0 to 1023, maybe 0 to 300. So there's some nice convenience functions like that in Johnny 5. In our draw, we're just going to draw our output. Okay, so let's try that out. We're going to hit play on the sketch. Sure enough, we get an authorized device. I'm going to pick that device out. You can't see the little authorization dialog just because of the way I'm screen recording, but a little dialog popped up in front of the browser. And okay, here we go. So I am just going to turn this dial here, and that's going to change our sensor value. So in real time here, we are getting sensor value. So one thing I've sort of wanted to build is maybe a couple of potentiometers you can do an Etch-a-Sketch out of. So a real simple way here to get sensor data is just to create a Johnny 5 sensor and connect the pins. All right, I'm going to stop this one here. And all right, so that's sensors, right? So that is that's input. Now let's go to actuators. So when we make robotics, right, we want to remote control something. We want to have something move. So an actuator, so we have sensor. The corollary to that is an actuator by making movement happen from our code. And this is a servo. This picture I have is one of these small 9G servos. I'm also they come in different sizes. This is one is a slightly larger one here. But these are really cool because there's different types of servos. But this one here, we can basically set the value like an angle. We can say go from 0 to 180. And so imagine if this was hooked up to say a robot's arm, we can change its position just by moving a servo. So let's try that one out. Okay. All right, going to disconnect our cables from that potentiometer. And these are really cool because you can just plug, I'm actually going to take that off of our analog input. I'm going to plug that here into, sorry, I'll move that a little closer to the camera. And that I'm using that same yellow one to plug into the servo's data input. And going to plug in our power, plug in our ground. Now, in this case, it actually won't connect to that analog pin. It's going to connect to one of these. They're called PWM outputs. They have a little squiggly line next to them. I'm going to plug that into pin 6 here. Okay. Now let's give this one a shot. Now, in this case, I don't actually need any visual canvas or anything. I'm just going to, I'm going to just create the servo class and then tell it to sweep. So sweep in our code here means go from 0 to 180 back and forth. And we'll try that out here. And it's going to ask me to authorize the device again. And there we go. So the servo is now sweeping back and forth. So we now, from a browser, just using this editor, we're able to do actuating and sensor input, and pretty much all the other cool Johnny 5 libraries that I mentioned are all going to be available to us as well. All right, I will stop this thing from running. Okay. And okay, so we covered actuators and sensors. Can we sort of combine things up? And now we have this whole web browser in front of us, right? It's got so many capabilities that we can interact with. So let's do a little more here. All right. So one fun thing to do, and we did this at our first NodeBots event, is if you see like a goofy electronic toy at the store, you have a reason to buy it now because you can rip the guts out and it might have wires and stuff, and just mess around with them, see what happens. Hopefully you don't start a fire. If you do, put it out, whatever, not a big deal. Just have fun with sort of these types of electronics. So what I did here, this is a weird thing in the Halloween section. It was a skeleton that plays the banjo when you hit a button. I thought that's cool, but one thing I've noticed at our NodeBots events is that, yes, the programming is fun. The Arduino stuff is really cool. But the arts and crafts element, when we build our little cars or robots and things, is it is honestly been the most fun part. You can kind of build any type of robot with these Arduinos and ripping one of these electronic toys apart if you have enough, basically enough hot glue and zip ties and servos and whatnot. So let's just get into this. This one's kind of silly. Sorry. All right. Gotta move the camera around here just a little bit. Okay. So what I've got here is a little skeleton that plays the banjo, but he's actually kind of shy. Our skeleton here, when I look at him, he just kind of turns away. And when I look away, then he's happy to play the banjo and look at me. So how can we make that interaction happen? How can we make our little friend here real? Well, we have some really cool capabilities already in the web browser, right? we have the ability to get camera feed from from the webcam, but there's a wealth of things we can add to this. Not just audio, but we can say use TensorFlow JS. There's a really cool project, ML5JS, which sort of merges, makes it really easy to use TensorFlow JS, and there are plenty of P5 examples. Some of those do really, really cool things like picking out, your entire like skeletal frame. There's just all kinds of machine learning algorithms on top of a video feed that you can use. But for this purpose, I'm actually going to use something a little simpler. There is in Chrome a face detection API. So I want this robot to know whether or not I'm looking at him. So this isn't super accurate, but if we have a face detection API that gives us the position of our eyes, I'm just going to say, if one eye is higher up than the other, I'm leaning one way. If the other eye is up, I'm leaning the other way. And so, I'm doing our typical load board stuff. I'm doing a little bit of screen capture stuff here. Then I'm using the face detection API. And if we get a detected face, doing a little bit of drawing on here, and then determining if I'm leaning left or right, if I'm leaning towards the robot or away from the robot. And then, I can turn a servo a certain way. I can have him play. There was another wire in here to move his hand on the banjo. So let's plug this in. Okay. And I'm going to try running this. Okay, the same authorized device. Actually, I'm going to switch views here just a little bit. Okay. Okay. All right, so there's some face detection going on here. When I sort of lean over in one direction, the little robot friend here, he gets scared, he gets shy, and he looks away. When I tilt my head in the other, he is happy to play his little banjo, look at me, look back at him, he stops, look away. Anyways, if nobody else is entertained by this, I am very entertained by my skeletal banjo playing the Exorcist theme. So, anyways, that's it for hardware demos. So, okay, we've bridged successfully, Johnny 5, robotics, P5, visualizations, and that's just scratching the surface. We've got so much more we can do. There's, a lot of immediate next steps. AVR Girl, awesome project. There's a few boards that aren't quite working with WebSerial yet. We can do some more work there. I've done some web Bluetooth work as well, because maybe we don't have to have a wire connected to the device. We could maybe just use web Bluetooth to send the signals. But the big one here is, for me personally, is that I think we need more of the web browser vendors to get on board with some of these hardware APIs. And if there's any security issues around talking to hardware, let's iron that out. Let's say, this dialogue isn't good enough. The user doesn't understand that they're authorizing serial. Whatever the case is, this is really important because these are all open specs. And so we can build really cool, even useful things. Not creative coding is very useful for learning, if nothing else. But there's lots of practical applications for interacting with hardware directly from a web browser. And it also is, the web is distributed and there's no gatekeeping with just the web in general. So if we have Firefox supporting WebSerial or Safari supporting WebUSB, well, we can then build these applications and not be gated by potentially app stores. Sorry, that might even sound political, but I think there's a long way to go still on having sort of universal hardware support in web browsers, but there's been a lot of really good steps. Riley Grant at Google has done a ton on this stuff. There's actually some really good conversation going on Twitter around hardware in the browser. And I think I'm actually optimistic. I think a lot of really good stuff is going to come from this. And that's about all I got to say. Thank you for listening to this presentation. Bye-bye.
I will say a robot skeleton playing the banjo from browser only APIs. That is insane. How did you? What was your inspiration for this? How did you come up with this, Louis?
Well, I, this wasn't my first dumb idea, but it was the whole sort of creative coding, adding that to robotics. It actually started for me probably in 2018. That was at Cascadia JS. My friend Elegant Sky, she did a talk on creative coding in browser, and that she just articulated the idea of creative coding a lot better than I could have. But after her talk was Ruth John's talk, and she did this amazing talk on audio and visualization for audio. And I was lucky enough, to start pestering both of them to work with me on something, and they agreed. And my friend Mal here in Phoenix as well. She's an artist and a developer, and the three of them and myself, we got together and we made Node Art, which was at JSConf last year.
Which I got to attend, and it was like one of my best days of pure joy as a developer that I've had in like the past decade. It was so amazing.
It was so much fun. We built a MIDI controller, and then we took the input from that to do visualizations. So I since then I kind of wanted to take just Johnny 5 all together and see if I can combine it with this. And for my little friend here, my the Exorcist on a banjo. He just happened to be at Walmart. I'm looking for like toys to hack on. This is like, well, it's cool, right? Because I'm doing it for science. Robotics, I can go look at different Halloween toys, and like, oh, this one plays a banjo. I bet I can rip it open and see if there's motors and stuff in there. And sure enough, it was actually pretty easy.
Yeah, my son is on to this game because he's seen me build the MIDI box, and he's like, we were in Tokyo earlier this year. He's 6, right? And he's like, you have the Sony Abo dog, which is a $3,000 dog robot, right? He's like, Dad, you could get that and use it for HalfStack. And I'm like, and I actually gave it serious thought. And I'm like, yeah, I'm not going to spend $3,000 on a robotic dog. But it was like, he's all onto this. Like, you could do it for HalfStack, Daddy.
It's, I mentioned in my talk, but when we run NodeBots events in Phoenix, or International NodeBots Day, we start with just a real simple little robot chassis, and we put things on it. But once we get the basic robot going, people spend like 4 or 5 hours decorating the robot, gluing things to it, putting weapons on it and everything, because it's a battle bot at the end of the day. But I think the arts and crafts part of this is like a lot of fun, to be honest.
Oh yeah.
Getting things to move, awesome. Getting sensor data, awesome. But actually, physically building robots or adding things to these is a blast.
I completely agree. And like music and auditory stuff is a big part of that as well, just because it's like, oh, now I can make my robot make music. All right, that's cool.
So if someone's watching along at home with this, I'm sure they'll be able to get their head around Johnny 5 quite easily, but the hardware might be something that's new to them. Mm-hmm. You mentioned breadboards and you mentioned the jumper cables and things like that. Is that something you have to buy individually, or is there a kit you can buy?
There's plenty of kits. In fact, one of the best kits is the Johnny 5 Inventors kit, and that actually is it's a little more expensive of a board, but that board can run JavaScript on it directly. Mm-hmm. And I mean, you can basically write some JavaScript and have it move over to there, and then the thing can just run independently. Yeah. And that one comes with all kinds of wires and sensors and servos and things. Also, there's really cool stuff from Adafruit. There's, Arduino kits that just have, all kinds of things to experiment with. What's nice is once you have the ability to, set a firmware to it and talk to it with JavaScript, all of the little components you can still use, right? Just because you're not writing in C, you still have a way to interface this stuff. So most of the examples and things have been around, writing in C and Arduino, but there is pretty much, one-to-one of that type of demo and example on the Johnny 5 site.
Yeah, I actually bought the Johnny 5 Inventor Kit this year to do like Sunday robotics with my son. And mostly I hack on stuff and he makes YouTube videos, or like calls them YouTube videos. He hasn't published any of them yet, but he makes videos of us doing robotics together, which is kind of fun. But, basically like you take your breadboard and you light up some LEDs and you do some other patterns and stuff. And it's got a nice set of tutorials you can follow, which are actually So usually, historically, before Louis' node art thing, my history of hardware was it will catch fire before I see results. And then that day, like everything just worked. And now I feel somewhat confident that I can make hardware work, which is kind of cool. So if I can make it work, I'm pretty sure anyone else can.
Yeah, I think you can count on burning up a couple of little boards, or maybe releasing the magic smoke from one of them, or whatever. And that's just part of it. I've destroyed lots of boards in my learning of this thing. Hopefully you're destroying the inexpensive ones first. But it's not a big deal. Just that's just the way it goes. When you build things, sometimes they catch fire.
Yep.
Have a fire extinguisher somewhere nearby.
Well, I'm known as like the person who has never owned like a computer that didn't need serious repair within a year, no matter what I do or how careful I am with it. But maybe it's getting better now. So I know one of the things you also do in the Phoenix area is you are part of a group called Heatsink Labs, which has sort of a maker space. So obviously COVID kind of shut that down for most of the year, but it's picking back up a little bit on limited capacity. But how has this like impacted your ability to work on hardware stuff and experiments? Or were you still able to go in because you have like membership access?
I'm on the board actually, but you don't have to be on the board to have keys to the place. But I do have keys to the place as well. And so there's been something like I don't have a laser cutter at home, so I have to go in there to do the laser cutter. I have a soldering iron, stuff to do simple things over here, but and I have had the ability to go in there, but it's definitely put a damper on things to not have the whole group together, building cool stuff. And in fact, there wasn't an International NodeBots Day this year either, which there has been every year for several years. So that's a bit of a downer, and but that just means you have to make your own friends.
That's really hard.
Yeah, although as much as I haven't enjoyed being home all the time, my two little dogs, I got two French bulldogs, and they're ecstatic about COVID. They don't want it to ever end. They want me to stay home, I'm pretty sure.
Yeah.
There's a lot of pets out there in the same boat, I'm sure.
Yep. I remember from the previous HalfStack, I have the Chelsea Kluk. Well, you saw it in the Mario video. But I have the little Chelsea Klukas LED mask. And the app for it is okay, but it's not great. I would really love to see it's Bluetooth, right? I would love to see like a JavaScript Bluetooth pixel art app that can hook up to one of these. So if you know about one, share it with me. And if you don't, you should tell me how to create it.
Really good open source pixel art thing Jen Schiffer does. I imagine we could take that and then just add web Bluetooth to it. Whatever the protocol is to send the bytes over to that, it sounds definitely within reason to build something like that.
Nice. Well, that'd be a lot of given that COVID is probably not going away for a while, I think we should work on that. So this is conference driven development in action. So
the thing with browsers and Bluetooth, that API is actually at least a year older than the Serial API. In fact, Serial is still behind a flag. I think at least till Chrome 89, it's still just in origin trials. So probably not till Chrome 90 that it's working by default. But Bluetooth has been around for a while, so that isn't something that the API is changing much on. So we can there's some new features being added, but absolutely we should hack on that mask with web Bluetooth.
Yeah, that'd be great. I want that, and then I want to just like find a bunch of like open source stock pixel art, and just because I want like a different image or different animation every day kind of thing. I don't have time to like do that in a poorly implemented mobile app, so it's not as poor. It's just like it's got like it's a rough editor, so I would rather have something a little more flexible. So cool.
A minimum viable product.
Yes. Awesome. Well, thanks so much for the really fun demo and amazing talk. And
thanks for having me.
Awesome. Cheers. Bye.
Very enjoyable.
Bye.